Hello everyone, Nathan here from PH Studios, and welcome back to a networking tutorial. In this tutorial, we're going to expand on the previous tutorial and actually create a protocol that will handle user movement. Now for this tutorial, I did a few changes to the code, and instead of creating a 40-minute video, I'm going to break away from that. I'll code it as the tutorial's going along, and the full thing's complete. What I'm going to cover today is complete. And I'm just going to do it's completed, so I'm going to walk you through it process, basically. For this video, just because there's a lot of things that I changed. Okay, so the last video, or the last two videos ago, you saw an issue where one client, we start one client, everything's fine, we have a blue player at the very bottom. Then we start a second client. Now, sometimes, whenever we start that second client, we will get two blue sprites or two red sprites. Now, after the video, I thought to myself, well, that's got to be that I'm running in the same folder, so it's trying to get to the same image, so that's causing an issue. And the reason I thought that is because after that, I dragged my debug folder, I copied it to my desktop, and now I ran two different games that have access to different sprites, and then it worked fine. So that's why I edited the video to say that if you run the game in the same folder, that this might happen sometimes. And that was actually a false statement, and I apologize for that. I did some more testing after that video. I ran it about 30 more times, and I found out that it only happens about 7 times out of 30. It might be higher or lower in some cases. It might happen 3 times in a row or once every 10 times or something like that. But it was roughly about 7 or 8 times for 30 attempts. And I realized something in my testing, that the first client, the one that we'd start first, never had the issue. It was just the second client. The second client would always have either 2 blue or 2 red, or 90% of the time it would work. Actually, 66% of the time if you want to be technical. But it would work most of the time, but sometimes it would fail and do the 2 enemies or 2 player sprites. So I thought to myself, even, why is this issue occurring? And I realized something. After looking at the code, I realized that in the initialize method, we had at the very top, when we first entered the initialize method, we set up to where the client would connect to the server and we would begin listening for messages. That was the cause right there. The issue was, the first client's connecting, okay, it connects to the server, we have nothing to get. We have no other client to receive information from. So that's why it always worked on the first client. When the second client connected, it performed its initialize method, and it immediately received information from the first client, and then we have 2 similar sprites on the game window, basically. So that's an easy fix. I just moved the client and read buffer and client.getStream lines to the very end of load content. Also, I already initialized the enemy in the initialize method. That way it's in memory, it's ready to be used, and we're good to go. Then, in the load content, before we set up our ability to receive information from the server, we go ahead and read the texture that we want to use for the enemy. So we put that in the load content, and I also changed it to where, since, let's go back to the connected protocol. If you remember, we had it to where if enemy is not equal to, if enemy is equal to null, it would perform this information down here. However, if I initialize enemy in the initialize method, that would never happen. So what I had to do is I created a boolean that says enemy connected, and that's initialized to false. So when we process the connected protocol, if the enemy is not connected, we set it to true. It's connected now. We set the rotation and the position, and we need to send the verification message, basically. If it's disconnected, we simply set it to false. Okay? In the draw method, I initially had it to where it said if enemy is not equal to null, enemy.draw. I'm reading the top line as I try to say the bottom line, so that's why I said player. So it was originally if enemy is not equal to null, enemy.draw. So I changed that to where it says if enemy is connected, enemy.draw. So if the enemy is connected, we want to draw the enemy. So those were the basic changes that I made. You just want to be sure to start the listening process after the load content. Now, sometimes it was an issue, sometimes it was not. I'd never experienced it until the very end of that video, which is kind of weird that I never experienced it. But anyway, that was an issue, and I apologize for what I said before, where if it's running in the same folder, that was the issue. That was not. It was just that it was receiving data right away. So anyway, that's how you change that. So on to the tutorial, which is processing movement data. So we want to process data to where if the player is moving, we want to actually view that information on the other client. So what you want to do in the update method, we want to get a local copy of the player's position. And we want to get a local copy, which means we need to create a new object, a new vector2 object of that data, because that new object cannot be interfered by the update method here. It's a brand new object, just has the same data. It's completely separate from the player.position object. So we create a new object that has the same data as the player.position object. So we store our position.x and position.y. Then we get our movement vector, which means we need to calculate a keyboard press. We need to determine what keys are pressed and what to do if they are. And just like always, we want to create a movement vector. And if current.isKeyDown, keys.left, if we press the left arrow key, we want to set the movement vector's x value to -10, or some speed value of your choice. Now, since we have that using system.windows.forums at the very top, we need to provide the full name of the actual keys.left, the keys enumerated type. So we need to say current.isKeyDown microsoft.xna.framework.input.keys.left. It's a very long thing to do, but if we want to have a message box, that's what we need to do. Alright, so if we press the right arrow key, we need to set the movement vector's x to +10. So if we press left, it'll move left with a speed of 10. If we press right, it'll move right with a speed of 10. Then we set the velocity to the movement vector. Then we update the player object, and this is using the gameplay object, so you just gotta remember that you call player.update and everything will be taken care of. The position will be updated based on the velocity, and the rotation will be taken care of, and all that stuff. Now we need to get a local copy of the new position, which is just the same thing as the I position. End position is equal to the current position.x and current position.y. Finally, we need to calculate a delta position, where we subtract the new position with the old position. So we call dot subtract n position, comma, I position. Okay, so now if we did not move at all, of course it'll be a vector of 0. If we subtract 3 with 3, we get 0. So if delta position is not equal to 0, which means something we did move somewhere, we want to send the information to the other client because we did move. Now, there were two ways that you could set this up. You can do it the way I'm doing it here, or you can do it another way, which is you basically have a state where if you're standing still, you do not send anything. If you begin moving, you have a state that's called moving. So when you go from the standing still state to the moving state, you want to send your velocity. And when you go from the moving state to the standing still state, you want to send a 0, 0 velocity because you're done moving. Now, both have their advantages and disadvantages. With the sending velocity instead of sending the position data, when you're sending the velocity, you send it once when you're beginning to move, send it the second time when you're done moving. You're sending 0, 0. Now, that can be an issue if you're sending it once and then the player disconnects. Before it processes the disconnect protocol, it will still be moving and things can just be weird, basically. I'm sure you've seen that in some games where a player will just keep on moving even though they got disconnected or something like that. They're still moving, they're stuck moving forward, and they just got to close it and open it up or something like that. So that's one of the disadvantages with the sending the velocity. With the way we're doing it here, the only disadvantage with this is we're sending it whenever we change the position, basically. So we could possibly be sending this 60 times a second to the other client. So whichever way you prefer, you want to go with. If you want to send it twice and be aware of that issue might occur, you could do that. If you want to just send the position data, you can do that too. If you're, for example, if you're targeting this game for across the world, like overseas, you probably want to do the second option, which is sending the movement data instead of sending the position. Because that way you don't send that much data and there's a lot more chance that it will get through. But since I'm using the same gameplay and the same house, it doesn't really matter which one I send. It's pretty much 100% because it's right next to my other computer. I have two computers right next to each other, so it's pretty instantaneous. So anyway, those are two different ways to do it. I chose the position one, and we'll go with data integrity in a future tutorial. I'll discuss data integrity, and that'll help things out a lot too with the data integrity. Okay, so that's what we're doing here. Whenever we are moving, whenever the difference in the initial position and the new position is different, we're sending a new position value. However, what we're sending is the difference. We're sending the delta position dot x and delta position dot y. Now, in the protocols, I created a new protocol called player moved is equal to 2. You want to put a comma after connected is equal to 1 because we created a brand new protocol. So we send that protocol, player moved, and the server does not need to know about that protocol. Remember, all the server is doing is relaying messages from one client to another client. Before it sends that message, it is applying the ID and IP address to the end of the message and then sending it. But it does not need to know about all the new protocols that you're going to create. It just doesn't need to know that. It does need to know about the connected and disconnected because it will send messages based on those protocols. So anyway, remember, in the very first few videos, I mentioned that we always want to send the protocol first. That way we know, we read the protocol, and then we know what to expect in the message. So we're sending the protocol, and then we're sending the X and the Y values, which are float. Alright, so now we go into the process data method. We have a if P is equal to protocol.connected. It's not the connected protocol. Else if P is equal to protocol.disconnected. It's not the disconnected protocol. So I had to create a new else if. Else if P is equal to protocol.playerMoved. If it's a player moved protocol, we need to read the X and then read the Y in that same order. Now, it's a float value. And I mentioned that in a few videos ago that if you're reading a float value, it's called read single. Float is sometimes referred to as single. I think it's called single in Visual Basic, no matter what. But anyway, if reader.read single reads a float. If you want to read double, it's read double, but if you want to read a float, it's called read single. So we wrote the X value before the Y value. So we need to read the X value before the Y value. And then the ID and the IP, which is a server appending to the end of every message. And then we just set up the position based on the difference. Now, it is the difference. So we have enemy.position. We need to create a new vector 2. We need to add the difference, which is px. Enemy.position.y plus py. So we need to add the difference, and then we get the new corrected position. Alright, so that's all the changes I made, and it is a pretty complete looking movement code. So let me run the game, and then I'll run the game in another client. Alright, so I'm going to move the ship on the right window, which is the second client that connected. Watch the left game, and then you'll see what happens as I move. Now, it's moving pretty slow, but you get the idea. Now, I only enabled the left and right movement. I'm sorry, I can't talk today. I said I about 6 times there. But I'm only allowing the left and right movement for now. So when I move to the left, it moves the enemy on the client to the left. Now if I switch it, if I move the first client, it'll move the second client's enemy. So we got a completely working movement data. It just moved the left and right, but if that's what you want, you do not want it to move up, and then you'll get all sorts of collision detection going on. But if you want it to move up and down, you just create 2 new else ifs. If keys.up, we want to set the movement.y to negative 10. Else if keys.down, we want to set the movement.y equal to positive 10. Alright, so now we run the game. Then run the game again. And then we go ahead and do that. However, it's updating the opposite way. I'm moving up, but it's actually moving up over here. So what you can do to fix that is in the process receive data, instead of plus py, we can do minus py. So now if we run the game, then run the game again, 2 different clients, let's go ahead and now everything looks correct. I move up, which means it's pushing it up. I move down, it's pushing it down. And that's really the only way to get around that situation. Because I'm moving up, it's going in the negative y direction, but in the left window, it needs to go in the positive y direction. So that's moving way too slow. So what I'm going to do is I'm going to set the float speed is equal to 50. And then I'm going to replace 10 with speed everywhere. I'm going to keep the negatives. I'm just going to replace wherever it says the number 10, I'm going to put speed. And it's about 5 times faster. It's still a little bit slow. Say 90. There, that should be quick enough. Alright. So now, let's go ahead and run it. Run the second one. Let me rearrange the windows here. And I'm going to move the second one. Alright, so our movement code is pretty much complete. We can move up, down, left, and right, and it's pretty good. So that's pretty much it for this tutorial. It was a pretty long tutorial, even though I had the coding done. So just think how long it would be if I had to code it during the video. That's why I did it this way, only for this video, because there was a few changes. Okay, in the next video, we're going to talk a little bit about data integrity, and we're going to talk about it because if I move my player right here, then I run the game here, look what happens in the second player's screen. Well, that's not right, is it? That's not the same, is it? So I can cheat. I can kill you now, even though you don't see me. So next tutorial, we'll talk about data integrity. When we need to re-authenticate the sending, we need to provide it with the position X and position Y. Because we will need to know that information. Unless you want it to have it no process movement. Again, there's 100 different ways you can do anything I mentioned here. You can have it to where your keys you can't move your ship until another player connects it. If you want to do that, that's the easiest solution. However, if you have a game where you have to wait a few seconds to find somebody, you might want to play around with it, move a little bit, and all that stuff. So anyway, just some things to think about. I will go ahead and talk about the data integrity a little bit, trying to get things synchronized between the two different clients in the next video. And we'll go from there. So anyway, just to recap this tutorial, we discussed the issue with the multiple textures being displayed in one of the clients. We'd either get 2 players or 2 enemies. They were in the right spot, but we got 2 players or 2 enemies. So I discussed that the reason is because we are started listening for information from the server before we called load content. And then I also discussed a way to store the information into memory before we do anything with the enemy. So we store the enemy into memory, and we store the enemy's texture into memory before we even begin listening for information from the server. So that was an easy fix. The next step of this tutorial was to create a way to handle movement. And we needed to create a new protocol, a player moved protocol. You can name it whatever you want. You can set it to whatever number you want. But we create a player movement protocol. And I discussed 2 different ways you can do that. You can handle it based on the position. If the position is different before you store the position before you move and then get the position after you move. If there is a difference, that means you actually did move and you want to send the position data, the difference, to the other client. That was one way. The other way is to actually have states built into the gameplay object to where you're initially standing still, then you move, then you standing still. So when you transition from one state to the next, you want to send the velocity data and any changes to the velocity data. Then when you change it from the movement to the standing still, you want to send a 0, 0 velocity saying I'm standing still. So those are two ways you can do that. But I chose the position value. And in the process received data, we need to have another else if for the player moved protocol. Then we need to read it the same way we wrote the data. Then we need to read the ID and IP. And then we need to set the enemy's position based on the difference, which is plus the X minus the Y. And that was it for this video. So I hope you enjoyed this video. I hope to see you next time. It was a pretty long video. My mouth is getting dry. You can probably hear that. So I hope to see you next time.